Hello everyone, welcome to mentorbuddy.com. This is your mentor Gurvansh, and today we are going to learn about simple linear regression. Till the last topic guys, we studied about the EDA and the data pre-processing which we do to make our data set usable by the machine learning algorithms. So from here on we are going to start with first the regression problem statements of the supervised machine learning. From the regression statement, we will go to the classification problem statement of supervised learning. Then we will switch to unsupervised learning, in which we are going to learn about different algorithms. And then the last part is going to be about an algorithm of the reinforced learning. So here guys, the supervised machine learning is basically divided into a set of two problem statements. So when we are talking about supervised machine learning, the problem statement, we have two kinds of problem statement in supervised machine learning. One is a regression problem statement and the second is the classification problem statement. In regression problem statement, we find a numeric answer as the output, a numeric number as the output. In classification problem statement, we find the category as the output, or we do the classification. So we have a categorical output over here, or you can say that we have a discrete output in zeros and ones and two, means we are trying to classify in a certain kind of category. We are trying to classify our input as a certain kind of category. We'll start with regression problem statement and then move to classification problem statements. In the regression problem statement guys, we start with simple linear regression. It is easiest to understand. We'll move on to multiple linear regression. Then we are going to move on to non-linear regression. So for non-linear regression, also I have prepared some algorithms to teach. Okay, let's go back to our PPT and learn what this simple linear regression actually is. So guys, a simple linear regression can be mathematically explained by this particular equation where we have y is equal to ax plus b. Now this particular equation looks a bit similar to the line equation in mathematics, which is y is equal to mx plus c. So we are just following this almost the same concept. So the y over here is the dependent variable or the output which we are seeking, a numeric output which we are seeking. X is the independent variable or the input we are feeding in our algorithm. A is the coefficient of the independent variable x, and b is the constant value in the particular equation. So in a simple linear regression guys, we form a linear equation between x and y this following equation: y is equal to ax plus b. So when we feed the data set inside the algorithm, our data set tries to figure out this particular equation. Specifically, our data set tries to find out the values for a and b. So whenever in the future, whenever we give the value for x, it is able to get the output value y. So the simple linear regression can be explained by this particular graph which we have made, showing a positive linear relationship between two variables, experience and salary. The experience is the x variable and salary is the y variable. Now when we talk about the experience, so the problem statement over here says that depending upon your experience in a certain field, your salary should increase. That is the general problem statement over here. Now the line, this particular line is known as the regression line or forecasting line, which is formed with the help of the previous equation I just showed. Let's take an example. Let's say at a certain experience, certain year of experience, you are getting a salary of 30k. Now when I say that I have a increase of 1 year, my salary is increasing by 10k. Now this is the relationship which we are seeking, that in the increase of every year in your experience, your salary is increasing by 10k. So this is the equation we are seeking. This is the output which we are looking for. Now when we try to solve the linear simple linear regression, we again will start by importing the libraries. We'll import the data set, separate our x and y. As it is a part of supervised learning, we separate the x and y. Split the previous data into training set and a test set. Train our model and get the output. Once all of this is done, we plot the trained data and the test data. Now guys, when we perform this particular simple linear regression, in this regression we have to check how good our model is doing. To check the accuracy level of the model, we try to find out certain parameters. What are these certain parameters? So the parameters which we try to find out are the errors of the model and the R2 score of the model. The R2 score of the model can be directly given as the variance explained by the model, variance explained by the model. Okay, let me use the variance explained by the model divided by actual variance of the model, divided by the actual variance of the model, which gives you the actual variance of the model, which gives you the R2 score, which tells you how better your model is doing. Or R2 score is also known as goodness of fit, how good your model is fitting the data, goodness of fit. Now what are the errors? So the errors which we try to find out are MSC, RMSC and MAE. Now how do we calculate it? So as you all know, the error, general term for the general equation for any error is equal to original value minus the predicted value, right, which is the error. Now when I take a plot for the regression equation, let's take a normal plot for the regression equation. Now let's say I am marking my points over here. So let's say these are the points, these are the original values, okay, these red dots. Okay, now this particular blue line, let's say, is the regression line formed by the model. Now this regression line will try to go through the values very closely. Okay, now to find the error, what actually is the error over here? This particular perpendicular distance between the, okay, let me reduce the size. So this perpendicular difference between the original data and the predicted data is known as the error. Now if you look over here, some of the values are below, okay, some of the original values are less than the predicted values, some of the values are greater than the predicted value. Because of this, the error can be positive or negative. Now you might be thinking, sir, we are calculating the error, but what is the significance? So the significance over here is, in a regression model, our end goal is to reduce the, in regression, our goal is to reduce the error. To reduce the error, the least amount of error we have, the better accuracy we are getting. So when we calculate the error of this model, there will be some positive errors, there will be some negative errors, right? And also we need to take the total error of the whole model instead of getting the individual errors, right? So what we do is that to get the total error, what we do, we take, first we do the summation of the errors, y output minus y predicted, and then we take the mean of it. So we can say by y bar, right? So this becomes mean error. This is the mean error now, which identifies the total error, summation of n is equal to I is equal to 1 to n, or n is equal to 1 to I, right? Now since this particular error can be negative and positive, and if we add them, the error will reduce, but we do not want that. So we have two ways to make our error positive all the times. One method is known as taking the absolute of this particular summation values and then add them. So absolute of these, summation n is equal to 1 to I, where I is the maximum number of rows, divided by y bar, which is the mean. So this becomes MAE. This is the MAE now, mean absolute error. Now what is MSC? MSC is mean squared error, where you take the square of this particular error. So y output minus y predicted whole square divided by y bar becomes MSE, mean squared error. Now since we are taking the square of the error, the value is still huge. To reduce the value further, we take the root of our MSC. So we do like this: summation of n is equal to 1 to I y output minus y predicted whole square divided by y bar, the whole value, and this becomes RMSE. So these are the parameters which we use to see how well our model is doing. Now everything depends on these particular values. Now guys, when we start plotting our, so last part of our any kind of machine learning is to try and plot the values, try and visualize the output. Now when, as you saw in the equation, when you have two variables, y is equal to ax plus b, now we have two variables, b is the constant value and we have two variables x and y. One is independent variable x and the second is the dependent variable y. When you plot y and x, we need two dimensions to plot, right? So it is making a 2D plot over here, so we are going to do the same thing. So these are the things which revolve around the simple linear regression. Now, thank you guys for joining us on Mentor Buddy. I hope that this simple linear regression topic was clear to you. In the next part, I'm going to show you how do we actually perform simple linear regression in our Python programming language. Thank you guys for joining.